MAP4C, day 5, lesson 1.4, the Sine Law Part 2. We just talked about how sometimes using the sine law, when we do the inverse sine to find angles, that there's two solutions, and we have to be, aware of whether we want the acute version or the obtuse version, or maybe both. And then now we're in example 2. We're asked to solve the triangle. Remember, solving a triangle means finding all of the sides and all of the angles. So what are the things that we don't have? Well, we don't have angle M. We don't have angle N. And we don't have side N. So we got to keep working until these things are filled in. All right, well, let's start somewhere. Start at angle M. So notice that we've got an angle side pair here, and that's the one we're going to use in the sine law. Sine of M over M equals sine P over P. Substitute in. Solve for our unknown. And that you should be able to put right into your calculator exactly as it appears. 123 times the sine of 23 divided by 53 gives you, or should, about, let's see, 0.9068 rounded, but that's not exact. And then the inverse sine of that. And again, inverse, whenever we're doing the inverse sine, that's when we worry about, the two cases. There's two solutions to this. Right, and our calculator gives us 65 degrees about. Now notice, in this diagram, that's not 65 degrees. That's an obtuse angle, isn't it? So if angle M is obtuse, 65 isn't the answer we want. This is the little extra step that we have to do. So I'm going to say M is obtuse. So and that's 115 degrees. And that's our first unknown we have. And notice angle N, we could go through a sine law, I suppose, but let's just use angles of a triangle, right? Oops. Angle N is 180. Subtract 115. Subtract 23. That means N is about 42 degrees. So that means we've got that's 42 and that's 115. And so now we can find our last unknown side N using the sine law. I said that you could probably use just a substituted version in if you're careful, and I'm going to try that here just to see how that's going to look. So side N over the sine of N, which is 42, is equal to, and I'm going to use the pair that I'm given, side P is 53 over the sine of 23, P is 23, and then I'm going to use that to find side N. You pound that into a calculator, and you should get about 90.8, and the units are millimeters in this case. Okay, triangle solved. On to example 3. I think example 3 is probably one of these real-life applications. Yes, and indeed it is. The angle of elevation from one side of a mountain is 48 degrees to the top, and the trip is 8.3 kilometers. From the other side, the angle of elevation is 62 degrees. Okay, well, let's draw a diagram. That's the first step. There's the ground, the horizontal. And remember, from the horizontal, that's from one side of the mountain, we're looking up at the top of the mountain. From horizontal, that's the angle of elevation, right? And so that angle there is 48 degrees. It says the trip up, this is the top of the mountain here, the trip up is 8.3 kilometers. Then it says from the other side of the mountain, the angle of elevation, oops, get my line in there, angle of elevation from the horizontal up to the top of the mountain, that's 62 degrees. 62 degrees. All right, now what's the question? How long is the descent down the mountain? So this was us going up, this is us going down, that's the unknown right there. And notice we've got an angle side pair, means we can use the sine law. I'm going to use, well, obviously we don't have any letters, I'm going to use the substituted version. Side x is what we want to find over the sine of the opposite angle. Sides on the top. Sine of the opposite angle, cross multiply. Calculator work, 8.3 times the sine of 48 over the sine of 62, and I got about 7.0 kilometers. So word problem, word answer. The descent is 7.0 kilometers. B. How much distance would be saved if there was a tunnel through the mountain? So we can see up and down is the two things that, the 8.3 and the 7.0 we just found, but we need to find this distance here. I'm going to mark that on there as D, and we got to find that. Notice in order to use sine law, we need an angle side pair, which we have, but we don't have the angle that's opposite the side we want to find, this angle D here. Well, that's not so bad because I can just use the angles in a triangle. D's 70 degrees. And so now I can use the sine law a second time to find out how long our tunnel's going to be. Use our angle side pair, sides on the top. Cross multiply. And I got from the calculator that was about 8.8 kilometers. Now notice, that's not our answer. Our answer is how much would we save by using a tunnel. So the total up and down, that's supposed to be a U there. Nice. Is 8.3 plus 7. That's 15.3. Then the savings is the difference, right? I can go 15.3 subtract 8.8, and that's 6.5 kilometers. And again, a sentence. That's it.